Woo!
Yeah. Hello, everyone, and welcome to Getting into Vault. This is episode 4 of this series. Wow, we made it past 3 episodes. You're still watching up to this point. We're so happy you're still tuning in with us. I'm Rosemary. This is Melissa. We work on the community team at HashiCorp. And we are here to learn Vault the very, very difficult way, which is to manually issue a bunch of commands uh, and solicit suggestions from chat on what we should do. Sometimes it descends into chaos. Sometimes it descends into very broken clusters. But, we're not here to show the perfect path. We're here to show what it means to learn Vault imperfectly and to do all the things that might fail. So we are here for that. As usual with this series, if you would like to interact with us, we do welcome that. So put your hellos in chat, put your questions, your suggestions, your thoughts on next streams. I will preface this in that we've had a lot of requests for Kubernetes. I promise we will get to it. It has been the plan. And for those who are big fans of Nomad, there will likely be a Nomad one. We might need to get an expert on Nomad on, though, to help us with that. But as you interact with us, please be mindful of others in chat. Please be respectful, be professional, and be welcoming. If you have any questions about our community guidelines, there's a link that I'm putting on screen here. So we do welcome all your questions and we do welcome all of your concerns. And we just want to make sure that as you do, be professional as you interact. And with that, as another note, we've also gotten a lot of questions in chat about where do you find the other parts of the series and where do you find the recordings for these. You can find them on YouTube. I imagine you're tuning in across LinkedIn, Twitch, YouTube, etc. We do have a playlist available so you can watch all of the previous episodes that have led up to this point, but it's not always a prerequisite. So if you've missed the previous episodes, that's all right. But we kind of start each one depending on the concept that we're learning. With that, Melissa, would you like to give us an overview of what we learned? It's been a couple weeks since we streamed, so.
Oh goodness! So we've learned how to install Vault and set up a KV store, essentially, yeah. And then set up RAF storage for Vault, and then we learned about Vault clustering and how to build and break Vault clusters and what happens when they break, which was very useful.
Yes. All right. So I'm going to, because by popular request, I have a deck of diagrams now. I finally got to it. I'm sorry, everybody. It took a while. It was a bit busy. But as another note, this is our tentative stream schedule. Things are going to change. But tune in to Hashi Talks next week. It's our 24-hour event. It will be taking over our streams, which is why we are not going to be streaming on next Friday. But after that, we'll have this rough approximate sequence of episodes. No promises, though. So if we can't get through certain concepts, we'll move them into a different episode as well. So this is subject to change. But for those who are asking for one, I have it available now. I also have a bunch of diagrams. As Melissa mentioned, in part 1, we learned about installing a Vault server on an EC2 instance or an AWS virtual machine. We distributed a bunch of key shares. This is where you call this Vault operator init. It gives you a bunch of key shares. We use those key shares to decrypt the Vault root key to decrypt the Vault encryption key. And then that entire sequence of what is called shamirs or unsealing, sealing, unsealing a Vault eventually decrypts the Vault server and the information that you have with it. So that's a very rapid overview of what happened in part 1. We did unsealing. We also, as Melissa mentioned, put keys and values into Vault's KV store. So that had some credentials and a password. In part 2, we did 2 methods of building out a highly available Vault cluster. The first is that we did a manual join by IP address. There's a bunch of stuff here, but we created an active Vault server, manually joined by IP address, and then we had the Vault server, a standby Vault server joined by IP. And then we did a second kind of configuration where we had the Vault server that's on standby, a second one, joined by AWS tags. This is called auto join. Now we're talking a lot about AWS in this stream, but a lot of these concepts will map to most of the major cloud service providers as well. So there's auto join for a number of the cloud providers. This is a general approach to having 3 Vault servers. So if one fails, specifically the active, then it will elect another active server, and you will still be able to access anything that you have in Vault. Eventually in part 3, we changed it to fully auto join, which is where we are today. Everything is joined by auto join. We don't manually go into each server and register the Vault server as a standby. Instead, everything automatically joins because we are automating everything. We also talked about auto unseal, where basically you store all of the key shares into some key management store somewhere. So in this case, AWS KMS, or not the key shares, you store the decryption of the Vault root key into some key management system. In this case, AWS KMS, which decrypts the Vault root key, which decrypts the Vault encryption key. And then we learned about the 2 steps. If let's say you compromise your root key, you can use Vault operator rekey to rekey it. And we also have Vault operator rotate to rotate the Vault encryption key. So if either one of those keys are compromised, you can rekey and you can rotate. So that's the rapid overview of this part 3. Any questions, Melissa?
No. Great stuff.
Since we're going through this, I know folks were like, we need diagram. So I said, all right, I'm going to finally build up the diagram. Today, we are going to be talking about cluster backup and cluster restore and probably token authentication. It turns out it's not just, we've been using root tokens, much to everybody's chagrin. Don't worry, we revoke these root tokens at the end of each stream. We revoke the root tokens, but there are a lot of other kinds of, there are other tokens that you issue for Vault, especially if you have services that need to access Vault. You'll want to issue a token, a Vault token for that specific application or something. Helps it narrow down the blast radius. You don't want to be issuing root tokens to all applications. So hopefully we'll get to that. But today we're going to have chaos. Not chaos, but I'm going to acknowledge this, Melissa. I have never done this backup and restore manually. So
Yay!
We will see how it goes. I don't know how smooth it will be, but we'll give it a try. So if you will bring up your Boundary instance. Sorry, Boundary desktop. As a preface to folks who are tuning in new, Melissa is using Boundary to proxy into Vault servers. The reason being is that this means that I don't have to share a bunch of SSH keys with Melissa. It sorts it all out, and Melissa does not have to know about too much about AWS or too much about Terraform in order to do this. So we are going into each machine via SSH. Here, you'll notice I have pre-staged a few things. There are 2 sets of targets. Yes. The first is our original set of Vault servers that we've SSH'd into. And then they have a second set, which is nothing has been configured. That's why it's called green. Yeah, I labeled it green because we're going to do effectively a blue-green for cluster, snapshot, and restore. The reason being is that it's going to be just too challenging to try to reset all the servers. So I just created a new set of servers that we could just back up into. So we'll see. We shall see how that goes. We do have a question about how to find the recorded videos of part 1 and part 2. I will put up the series URL again. You can find that at hashi.co/gettingintovault. You'll find parts 1, 2, and 3, and part 4 will join. Okay. All right. So then, Melissa, let's get started. Let's connect through the Vault servers SSH.
Anyone?
Any one of them. I don't think it matters. I don't actually know which one's the active one.
Okay. I picked the middle one, so we'll see.
Okay. So as per our usual sequence, we have our start. Yeah. sudo dash.
Yes. Brains this morning. There we go. We're here. So.
Yeah. Okay. So what we're going to do is if you do vault CA cert. I don't know if you remember that command, but remember we're bringing our own self-signed cert to interface with to put it in front of the vault server. So we have to define that certificate. So, yeah, if you do vault status, for example, right now, you'll notice that you'll get an error message back.
Yeah. Okay.
So we need to do that vault CA cert. Yeah.
The export. Okay. This is like that, right?
Yep, that's it. It was opt vault.
Oh, okay.
Yep. And then it was TLS /ca.cert. Yep. All right. Okay, so let's check the status so that people are aware of what's going on. Okay, so what is the status of this vault cluster?
It's initialized and unsealed.
Mm-hmm. And is it using auto unseal or a manual seal or?
I'm gonna say auto unseal because of this AWS KMS thing here.
Mm-hmm. That is correct. Okay. And is this an active or a standby node?
Let's see. Standby under HA mode.
Yay. Okay. So now that we've determined this, excellent. We have a vault. We could do. Let's check what's the command to check members? Which members of the vault cluster are available?
Vault members? Is it just members? No. Vault maybe. I don't think it's operator for this.
It is operator.
It is operator. Okay.
It is operator. Operator is going to be specific to anything you do with Raft, right? Including checking out. Aha. So
because we need to export our API. Export.
Yeah.
What is it API token?
No, just token.
Just token.
Yep, just token. We're warming up.
Yes, we are warming up. It's taking a week off is not as easy as I thought it would be. So I assume it's here.
Yeah, somewhere in there is the root token, right?
Yes, right here.
Yep. Yeah, this is what happens when we take the week off.
And again, don't share your keys on video, y'all. We're gonna destroy all this stuff. So
yes. Yeah, for those who are curious, it is every time that we end an episode, I bring all of the manual commands and I put them into automation via Terraform. So that way I can remove the instances and create and reapply everything. Okay, so vault operator members. You'll notice that there are how many members?
There are 3.
Yes. And which one's the active one?
The active one is this 103 guy right down here.
Awesome. Okay. So basically, now that we have reviewed our cluster, let's put some stuff in it. I feel like with a true backup, we would have to put some stuff in it. I feel like an empty cluster doesn't really do much for us. So let's put something. It could be like a KV, keep the KV store, or create the KV store or something. I'll let you decide.
All right. So that was definitely an operator command to do that.
Let's start by putting KV. So if you go to the vault, help.
Mm-hmm.
So vault, just vault, I think.
Just vault help?
Just vault.
Okay.
Yeah, vault is good. Okay, so yes. Let's KV.
And then it's put.
Yep. Well, we need to put it somewhere. So remember, in the sequence of things, we want to always mount a secrets engine and then put the secret in the secrets engine. I know we did this far back in episode 1. So let's check if the KV secrets engine is even there for us. So let's do vault secrets list. Secrets indicates the secrets engines. For those who are getting used to the stream, secrets engines are where you put secrets, and secrets engines correspond to an API path, often called a mount path. So here you'll notice that we have cubbyhole. We'll get to that. Identity and sys, but we do not have KV in here. So let's enable the KV. So it's vault secrets enable. And then you can do help, dash help. And maybe that will give us some more information. Some examples, useful examples as well. Aha.
Okay. AWS, SSH, database, custom.
All right. 2C documentation on secrets engines. Let me pull that up. It's going to be vault secrets enable.
Okay.
Dash version equals two space KV. Yep. There we go. Okay.
Yay!
So we enabled, if you do a vault secrets list again. All right. So let's put some secrets in there. So now you can do a vault KV put.
Okay. Just that?
Let's check what other things we need to put into it, the commands and arguments. So we need mount, and there we go.
Okay.
Good example there.
So here, what is that?
Well, we don't. Check and set.
Here we go.
Yeah. Mm-hmm.
Okay.
You can put whatever secret you wanted there. This is a very simplistic backup and restore, by the way, folks. In reality, you probably have a much larger set of a lot of data in there, including policies, authentication methods, etc. But we do not have an opportunity to set those up right now. So we're just going to skip a bit of the process in terms of setting those up. All right. So KV, right?
Yeah. So just KV. Whatever after this?
Yeah, so put use password equals, or what, we have to have a name of the secret. So let's name the secret. It could be Melissa. It could be Narwhal. Yep.
Which I probably spelled wrong, actually.
That is correct. No.
Okay.
You had it correct.
Yeah. Okay.
Wait, how do we spell Narwhal?
It's fine. Okay.
All right.
Good?
Yep. Good. There we go.
Yay.
Okay. And just to be really fun with it, we can add a second version of this. So you can do bad password too. Okay. Yeah, I think that's probably as good. Pretty much good. Let's see. Do we want to skip to the process of actually explaining tokens now so that we can see if we back up tokens as well?
Ooh,
that would be fun. Okay. You know what? I'll talk about tokens now. I think that's worth a tangent, right?
Yeah.
Okay. All right. So Melissa is using what is called a root token. Basically, the root token has access to everything and anything, which is fine to a certain degree, except you don't want to actually give everybody a root token, right? And there are actually a number of different kinds of tokens available. We're going to go through some of them today, but we do want to create a new token just to sort of with a use limit, just so that it's kind of just so we see it. I think that's the appropriate thing to go for. Before we do backup, just to see if it preserves it, just to see if it's still valid. I think it's a good exercise in the limitations of understanding what's going on with backup, what's not. So let's see. We are going to create a token. So let's create a token. If you check out the vault token command, all right. So we have a create, and let's check out the create attributes. So a Vault token is a string, basically, that you can use to log into Vault. You can choose to renew the token. You can revoke the token. All of the functions that you need for secret to manage the lifecycle of the secret, you can use. And so we are going to create a new token with a time to live. If you're not familiar with what a time to live is, a TTL, it is the amount of time in which you can use that credential. So we can create a token that's maybe 1 hour, right? And you can use it for a certain number of times. So you'll see TTL and you'll see use limit. You can say that you're only going to allow someone to use this token twice, maybe. So we'll create the token with a TTL of, actually, before we do this, we also want to create a role. So, or check the role. So before we do this, let's actually check the policy, Melissa. Just like how you don't want, just like any machine and any access control system has a list of rules that someone can and cannot do, right? They have access control to a system. Vault has a policy system. So if you do Vault policy, I think list, I can't even remember.
We're about to find out.
Yeah.
There we go.
So there's two policies, right? You have a root policy attached to your root token. There's also a default policy. So if you do a Vault policy read, default.
Oops.
We're just going to use the default policy. And for the most part, there's not too much in here. You'll notice it's got some like some syntax in here that's kind of confusing. But Melissa, what does path mean? When you see path, what does that mean to you?
It's usually like a file path, right? Just
file path, API path. So anytime you define something in Vault, there's an API path, right? So the secrets engine that you just created has a KV file path, or technically an API path. And so Vault's policies are defined by these API paths, which means that when you tell let's say this token what to do, it has to have a valid policy that allows it to access certain paths. So this token, this default policy, if a token is going to use it, can access its own cubbyhole, can access sys wrapping wrap, can access lookups, all of these endpoints here. I'm not going to go too far into policy because we're going to write a lot of policy in a later stream, but we'll just use the default policy to attach this token because we're not going to assign more root tokens. I think it's better for us just to assign this policy to it. So create-ttl equals choose your time to live.
10 minutes.
10 minutes? Are we going to have a backup of this?
No, probably not.
Let's do 2 hours. You can do 2H.
I assume there's some kind of policy equals default.
Yep, that's exactly it. And then how many uses do we want to put on it?
Ooh. What, 20?
Yeah, we'll do that. Dash use dash limit.
Just like that, assuming it can type.
Yep, that's it.
That's it. So now I hit the red button.
Yep, hit the red button.
Look at that.
So
it's beautiful.
Yay! Now we're gonna copy all of these.
Okay.
just to be sure we have everything, because if we're doing backup and restore, let's verify that we actually have true backup restore, right? So we'll see what the limitations are, but because even I don't know. So here we go. We're chaos. Chaos. Okay, we'll go back to this.
Chaos. Yes.
Can you do a Vault token list? I wonder if it will let us see the number of tokens. Maybe. Will it? No. Sadness. All right. That's fine. But if you do a Vault token lookup, let's just see if we can look up this one. Okay. This is your current token. That's great. Okay. Accessor. So if you go down to the bottom, accessor output will not include the token. Oh no. Does that not equal? Can we put in a token? Accessor instead of a token. It's all right. I think, let's see. What other options do we have here? These are all the Vault default options, I think. Yeah, I think we have to set the Vault token, but I don't want to override your existing. Oh, accessor. Vault token dash accessor, and then
Okay.
we have an ID that we can use. So you copied the accessor field.
Mm-hmm.
So we'll copy that. Yep. So that's almost like an identifier for it. Doop. Yep. Let's see if this works.
Hold on.
Invalid syntax. Oh, it might be encrypted. I don't know.
No.
Might be. Hold on. Let's look.
Oh, no equals. Got it.
No, it might not be the equals. It's invalid syntax. I wonder if this is base 64 encoded. Oh no, it's just the equals. Okay.
It did not like that equals at all.
It does not like that equals. Okay, so note to selves, don't put equals in the accessor.
Yes, no equals, no quotes.
Okay, so here's the accessor. And we'll know, now we know that this token exists, right? So the reason why we go through this is that we're about to back up our cluster. Ideally, what should we see, Melissa, when we restore this cluster to a new one?
Oh, goodness. When we restore, we should see all of this stuff. We should see the new tokens. We should see the KV we created and the stuff in it.
Yep. So hopefully that happens, but maybe it won't. So now we shall do the process of backing up. I will put the link in on the screen. Let me pull it up so that we have it. I know some folks are not able to access the link, etc., because you're watching through LinkedIn. I will make sure to put it up on screen so that there's a record of it. But the links will usually be underneath the video in YouTube as well. So if you need to find it in a more accessible way, we have that for you. All right, so this is the data backup procedures we will be following today. We have a manual backup procedure, and because we are not using disaster recovery or performance replication, we're not using Vault Enterprise, we're using Community Edition. So we're going to just do the manual backup. The first thing we're going to do is Vault Operator Raft Snapshot, because and don't issue the command, just do a -- help. And then,
oops.
Yep. Okay.
Look
so remember, operator has operator commands. Raft means the Raft backend, naturally.
Yeah.
And now we have some nice, helpful commands. We have backup, restore. We have save, which is the current state of the Raft cluster into a file. And then you can inspect. So let us save the raft.snap file. And let's just do snapshot save. And then you can name it whatever you want, but raft.snap probably is fine too.
Uh-oh.
Aha.
We have a sealed file.
Aha. Well then. Incomplete snapshot, unable to read. Okay, so now we are going to Google.
I'm going to inspect the snapshot for fun.
Does it even exist? It doesn't exist.
No, it does not exist, which is good to know.
Uh-huh.
Because incomplete, I would be like, okay, what'd you save? Nothing. We saved nothing.
Okay, this is a very unhelpful situation here.
Well, we could try journal CTL, right? Would that help us?
Okay, all right. I found it. I found it through the power of Google. It is because we are on a standby node.
Oh, so we got to go to the other node.
We got to go to the active one.
Okay, we can do that. It was 103.
103, that's correct.
And
the more you know. Now we have to set all of the tokens and the CA cert again. Well, the more you know. I guess I didn't fully read the instructions.
It's fine. Opt, vault, TLS, CA.
I think we probably have to update this in docs. I'm looking and I don't see a very clear. Yeah, it's not in the docs. So I shall make a note.
Right.
Honestly, and it's let me make a note. Update docs with active node notation. Boop. Okay.
Oh,
yeah. By the
Lord.
way, folks, this is a great way to put in updates and corrections to docs as well. So this is we've had a very good time on other streams, taking in feedback and trying to update our docs and tutorial for it. So
Yay.
yeah.
We're also using this to help the developer AI experience get better, by the way. It's a lot of fun. I've been going through the streams afterwards and plugging in our errors and
you are very brave.
Trying to teach the AI overlords how to better help us
on our developer portal. If you actually try, if you're in the beta, anyone who's in the beta, but for the developer AI, the developer portal AI, it will give you limericks as well. If you ask it for limericks and nursery rhymes, it will do one for you if you ask it. So
I want a Vault nursery rhyme.
It's very entertaining.
That's crazy.
Yes.
Okay. So then Vault.
Let's just check this is indeed the active. So if you do Vault status, we'll just double check. Okay, it is indeed the active node. So now finally, I guess now we'll just do Vault operator RAF snapshot save again. Overlords. Please work. Oh no.
Please work .snap.
Yeah, that'll do. That'll do. I'll take it.
Hey,
I'll
look.
take it. Oh, look. Okay, well, let's see. Where is it saved? Aha.
Okay, so there's stuff in here.
Fascinating. So when we inspect it, it tells us what it backed up, as well as the size. So we've got some tokens. There are a couple of things here. There's some policies that count 3 policies. Interesting. Does it have KV in here? I wonder.
I don't see anything that says KV.
Well, we shall see. I think this is mostly the system though. So this is mostly system and core. But local mounts, they have local mounts in here.
Yeah.
Well, we'll see. I guess it wouldn't be explicitly listed. If you can you check the options under inspect and see if there's maybe more information? Maybe we can look for more. Depth. Oh, they have details. Details. Ooh. What's in details?
That's fine. I wonder if it goes here.
Probably.
Okay. Same.
Okay. Depth.
And it wants an int value for depth. I don't know.
I see. Okay. Let's do 4 because I'm sure it may or may not work. We'll see.
Oh my goodness, look, there's stuff.
There is stuff. Okay, so there's some stuff about the accessor and policies.
Some metadata stuff.
It's a lot going on there.
Lots of core stuff.
Mm-hmm.
Yeah.
I wonder. Okay, well, let's see if we can back up and then see how it goes, right? I guess that's the only thing we can do.
We'll do the backup then.
Yeah, we'll do the backup. Or
Can we just do the backup?
We did the backup. We did the backup. Now we need to get the, okay, so, all right, we did the backup. We don't know what's going to happen. We'll just guess. At best, we'll just guess. Okay, so now that we have the backup, let's do a restore. As I mentioned before, I have another vault cluster. We'll see how that goes. Although I'm pretty sure, bring your vault cluster with restore from backup. This may or may not work. We're going to assume that these vault servers are having issues, and we don't want to have them. How do you put this? How do we put this? We're going to assume that these vault servers have issues, and they've gone offline. We have a new set of servers available to us. In all likelihood, you'll probably bring the same ones back online. So I don't know if this will work, because this might just break it. So chaos. Here we go.
Let's break it.
Let's break it. The first thing we're probably going to need to do is download that snapshot somehow.
Okay.
Now the question is, can we go back? If you click the session on the ID, that one that it's still active. The first one.
Yes.
FIMX, the session ID.
This one.
Yeah, and then you go back to shell.
Yeah.
Can we download it? I don't know. Which where is it right now?
Good question. Right here.
Okay. Got it. Please work snap. Okay. So what I'm going to do, because I am pretty sure that I'm going to have to do this, I'm going to have to add a security group to do this. But how familiar are you with SCP?
It's been a while, but I used to use it all the time. So I'm sure it'll be like, it'll come back eventually.
Okay. All right. Give me one moment. I'm going to do this off screen so folks don't see my AWS metadata. But what I'm going to do is that I'm just going to open a security group to allow SCP. Because I did not open it. Existing referenced group ID. Here. Nope, that won't let me do it either. Cancel. Hold on one moment. We are editing some inbound rules. Delete. Add rule. SSH 22. Okay. All right. Save rules. Okay. So it should allow SCP. All right. So let's see. We have to go to the other cluster, right? Let's double check. How do we get to the other cluster? You need to reinitialize your vault cluster and log in with the new root token. Okay, so the first thing we're going to do is go to the other set of vault clusters. So go to the green vault cluster.
Any of these?
Any of these, and choose one.
We're going 103 to 203. I like that.
Okay. So yeah, see, that makes it easy for us to remember.
Yes.
So if you do Vault CA cert, you set that stuff up. So this is a completely separate vault cluster. We didn't actually explicitly look at this on the stream, so we're going to go through this now. But this is a completely different vault cluster. It's not the same one.
Oh, wait. Quotes are useful. What about the root token?
If you do vault status, you'll see that it's not initialized and it's sealed. So this is a completely new vault cluster. There's nothing on it. So we're going to have to initialize this. So if you can do a vault operator init. Yep. Let's see. Okay,
Look
you'll
at that.
copy this. Make sure you
Yes.
remember this is the green one. So the other one I'm labeling blue. The old one's blue. This one's green. We're doing
Okay.
effectively a blue-green deployment. But it's like if your first cluster is really, 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 really not, you're just not able to get it working again. You could build a new one, and let's see if we can restore. Yeah, so we will need that root token.
All right, let's go.
And then, all right, set the root token.
Quotes or no quotes? Quotes? I want to say it's quotes.
Yeah, either way, both work.
Okay. There we go. Token is set.
Yep. All right, so now we need to SCP a file from one place to another.
Do I want to hop back to that other one? Probably be easier to do it from the source, yeah?
It's probably easier to do it from the source, yeah. Let's do it that way. Just remember, it's 10.0.1203, I think.
Okay.
10.0.1203, 10.0.1203. People, remember that in the chat. Are we on 103? Yeah, 10.0.1203. Reversed. Okay, there we go. All right, so we're going to SCP the please work file.
Yes. So it's
yeah,
and then post.
I'm looking at the syntax. It is well, we put 10.0.2. Whatever it is. No, sorry, 10.0.1.203. 1.203, and then colon. Where we'll put temp. Put it in temp. temp/pleasework.snap. We'll do that. We're going to put it in temp because I don't really feel like dealing with various permissions and all sorts of things. So we'll just temporarily put that. Okay, let's hope this works.
Permission denied.
Oh, we have to use Ubuntu. Can you exit? Because just hit exit. Okay, let's go try this. Copy that command again. The SCP please snap.
Yep.
Unless it's not in this directory. Where is please snap?
It is in the root directory.
Okay, can we double check that? Yeah, ls/root. Oh, see? Okay. All right, let's go back to sudo sudash. Let's go back to root, and then we can log in by a different username. Okay. So let's do that, and then we'll do Ubuntu at 10.0.123.
Okay.
It's been a while since I SCP'd stuff. Now that I think
Yes.
about it. Most of the time, I'm saving it to somewhere else. Permission denied. Okay. It is probably because we are using a key pair. So hold on. SCP between EC2 instances. Notice we didn't practice this.
By the way, y'all, this is Sunshine, my cat. He likes attention.
Hi, Sunshine.
I'm sorry. He's very needy right now.
He's like, hello.
Now that
I
I've
need this.
into him, he's
like, please.
I will be your support animal for Vault right now.
Yeah, exactly.
It's okay, Sunshine. Please do not touch my keyboard.
Yes. Hello, everyone. So he's saying hello. Everybody's like, hi.
Oh, yes.
Generate the key pair. Oh, boy. All right. Well, I think, let me just double check syntax. Maybe we have syntax wrong.
It could be.
Well, we need the key PEM. So is the PEM. So let's see. Where is, can you do ls tilde. I don't think we have an SSH. Keypem. I don't even know if we have a keypem. That's the other problem. So like ls, yeah, I just do ls on this directory for a second. I think I have not keypem, just ls. Oh yeah, so it's just snap in there.
Yep.
Can you do which directory are we even in?
We in root.
Okay. I think we have to generate one. I really don't want to do this. Okay.
That'll be fine.
I know, but
This is
I don't want to do it. Upload your public connect from. The thing is, I don't think we forwarded it. I swear we forwarded it. We forwarded it. We forwarded it, but I don't think we did.
Okay.
And we are going through boundary. This is a bit of a conundrum, folks. Okay, so the reason why this is a little bit more complicated is that we forwarded it through boundary. And so I think that the key pair, because it's being forwarded through boundary, the session, it's not probably forwarding key pair.
So we might have to do this on the back end and then come back to this side.
I don't really want to SCP it into the boundary worker, though.
Yeah.
We could do that, right?
I mean, we could.
I didn't plan this out.
But, I mean, yeah. Let's do it. Why not?
Okay, let's do that. Let me pull up the boundary worker. Because we should be able to SCP from this one into the boundary worker, and the boundary worker into the other one. Very roundabout. Wow. Let me pull this up. Okay, so the boundary worker is 10.3.123. So if you can run that on that same command, but do it on 10.3.123. 10.0.3. Sorry, 10.0.3.123. Let's see.
It's thinking about it.
We're just thinking about it.
I'm going to consider that a win for now.
It's thinking.
Knocking on all the wood here.
But do we don't know. We don't know this. In the meantime, while this is happening, I am going to generate take out the boundary keypem for this. And then make sure I have it. Okay. Oh. Yeah, so this is also the other thing that I don't think we fully I was like, maybe we should put it in a bucket. That might be necessary.
Yeah.
Putting it in an S3 bucket somewhere.
Yeah. Might also show a little more of what you should probably do with these things after you run the snap instead of just leaving them on the server.
Yeah, you should probably put it in an S3 bucket somewhere.
That seems a little better than just kind of letting
downloading it.
A server that might break.
Yeah, exactly. Let me see. So we are. Let me go in. ls temp. I do not see it yet in there. So it's either stuck.
I swear there was something we could, like a flag we could add to the SCP command at one point that would give you like a progress bar or at least a bunch of dots. Yeah, so you knew whether the command was hung up or not. It's been a while.
Stop. We can do it. I'm sure if you do SCP-help, we can figure that out.
Okay. Yeah, I was just gonna Google it. So should I kill this?
Yeah, kill this and Google. This is the imperfect part of this process. One day.
Okay, here we go. Yeah, Google. Buddy. Personal space. Go on.
Which one is that one?
It's still Sunshine.
Oh, okay.
If Moonshine comes out, it'll be special. She doesn't usually like to be on camera, so she's the shy one.
Okay. Well then, this is going to be a bit of a conundrum here.
It'll be fine. Progress bar. Here we go.
Yeah. I mean, I think they would probably want to just make sure that you back this up regularly. I mean, unfortunately, there's a manual. Unfortunately, for a lot of this is done manually. There is an automated option if you're on Vault Enterprise, but if you're not, then you could run this with a script, run it regularly. scp-r is your key in your .ssh directory. Let's check. Is the key in the .ssh directory? ls.ssh. Let's see. No. So the complicated thing is that we ended up, it's proxying through the boundary worker. So that's where things are a little bit iffier. And we also have things that are under different users as well. So I feel like we either need to expand the permissions. Can you do ls/temp/ can you move the please work to temp instead?
Yes.
Or just copy it to temp? Not move, sorry, copy. To /temp. Mm-hmm. Yeah, let's do that. Okay, and then let's exit. All right.
Actually,
yeah, let's just check.
okay.
It's still under root.
I mean, is it?
Well, remember it.
Let's see what that does. I think that. Oh, that's read and execute. Shoot.
Well, we really just need to read it, right? We don't need to write to it.
Okay, we don't need to write to it, then that's fine.
Yeah.
We'll do that.
Okay. All right. So, all right, let's do this.
Y'all.
Yeah. So
okay,
let's exit. Yeah, and then let's just see if we can see it in temp. Yeah. Okay.
Yep, it's there. Or no?
There. Okay. Yeah, there we
go.
go.
It is. Okay.
So let's do SCP again.
Okay. We'll scroll up for that and cheat here.
Yeah, we have the tricky part though is that we are using AWS key pairs. So someone suggested scp-r. I don't know if that.
Okay.
I don't know what -r is. Maybe we should check that.
Oops.
Yeah.
That's not going to work.
I know, right? All right. So the other option, which is probably the better option, is okay. I am just going to add a policy that will allow me to write to this S3 bucket.
Yay!
Okay. Sorry, folks. You know what? I'm just going to share what I'm doing in Terraform because why not? We're here.
Yes, please.
Okay. We're here anyway. So for the people who are very intrigued about this, I just run everything and I create everything in Terraform before each stream. So I just fold it into this repository here. I created a bucket already, so it's just a backup bucket. And then I am going to S3. We're going to be able to allow read and write access, right, to that bucket. So I'm going to need list bucket. And I will tighten up these policies after the stream. This is temporary for now. Some of these things I could get Melissa to do in the console, but just for the speed of not turning too much on this stream, and to make sure that we actually have the Terraform apply. You don't have to sit and watch an apply happen for 5 minutes. Here we are. I'm just going to add the ability for the servers to do this, although we'll see how this goes. Okay. All right. So this should allow the servers the ability to do that, to go into the S3 bucket. So Melissa, we should be okay with the S3 bucket. SSH open, SSH is blocking it. All right, so let's go back to your screen and I don't think AWS comes default, and AWS CLI comes default installed on these. So we probably have to install the AWS CLI, because what we're going to do is basically install the AWS CLI so that we can use the AWS S3 command. All right, so let us install the AWS CLI.
Okay. Is that a package add, or is it different in Ubuntu?
I think it's curl, because you have to
curl.
Yeah, okay. You have to curl it. Unless we have some AWS heroes here. Let's do the AWS hero. Yes, great. We have AWS heroes in the audience. Do you have a suggestion for how we install this on the AWS CLI more easily? I mean, I'm looking at the instructions, and it's a curl command. So
let's go with the curl command.
Okay. I don't know. Do you want me to put it in chat, Melissa, while you take yourself off stream, and that way you can?
Yeah.
Okay.
Yeah.
Okay. Let me remove you from the stage. Oh, there we go.
Well, I mean, just kick me out. It's fine.
Oh, okay. Well, here you go. There's the command.
Okay.
Melissa is sharing her entire screen. That is why this is a little challenging. So we are taking it off.
I didn't want to create the whole endless
vicious cycle of things. Yes,
the endless vicious cycle.
Okay. Actually, you know what? We're gonna just what's the point to this? Let's just
Okay. So we got the command.
Okay.
And I'm gonna pop it in a boundary here. Look at that. Oh.
Well, we probably need to install that. All right, apt. Sorry, we're gonna go apt.
Okay, hold on. We can fix this. So it did download, yeah?
Well, it did download, but we need to. Oh no, it's like I think the command pasted wrong.
Okay.
Hold on.
So
the command pasted wrong. Let me.
Gonna do this.
Hold on. I'm just gonna run it, but apt install unzip. We're just gonna do it. I'm on the host right now. For those who are wondering.
Okay.
Yeah, so I'm just going to quickly run this, and then that way we have it. Okay. All right, it's installing. It's doing a big run of stuff.
Okay.
Yes, we're going to just do that. Okay. Now, if you type AWS help, AWS space help, now you should have it. Yay! Okay, Q. To just exit out of this.
Yes.
All right. So now we are going to hopefully have permissions to copy this file to the S3 bucket.
All right.
All right. So we're going to do AWS space S3 space CP. And then we're going to do the local path. So that's pleaseworks.snap. And then bucket URI. Bucket URI. What is the bucket URI? Hold on. We are going to get the URI.
Yes.
Choose the. Okay, S3 : / and then it is getting dash into dash vault.
Yep. Just like that?
Yep. Hopefully. If this doesn't work, then I don't know what to tell you.
And those are good slashes.
Oh, yeah. Good. Yeah. Hopefully. We'll see.
Just like that. Nothing else? No slash at the end?
No slash at the end. Getting into vault. I mean, we'll just put it in the root. I'm not going to make some folders in the bucket. File directory not readable. Can you do sudo su and then run this again?
Okay.
Yeah. Yes. Good comments in chat. This is real life. Yes, this is very real life. Just sit here and just like.
I will tell you, so much of my career is trying to figure out how to get things copied to where they need to go. It's
yeah. So the
really
folks
sad.
who are curious of what is happening, basically what's going on is that we are using a boundary worker to proxy into our machines. And so when we are looking for the key pair is automatically injected, but not necessarily automatically injected and forwarded from the boundary worker, which means it's not locally saved on the machine itself, right? So it's great from a security standpoint in some ways because no one, including myself, neither myself nor Melissa actually know what the contents of the key pair are because they're automatically injected and forwarded through boundaries worker. But it also means that stuff like this, like SCP, we can't just distribute them at will and access other machines between each other. I did open up the security groups between these servers, but I suspect it's probably the identity that's really causing the core of the issue right now. So we have uploaded it into a bucket. Yay. And I'll even share my screen. Melissa, keep your screen share, but I'm just going to put this on for a second. We have now, we did upload it. This was the more successful option. So I think we probably should, just in general, I think if you're doing this, and even if you're doing a manual setup, you probably want to create this in a bucket somewhere, turn on backups, turn on versioning, make sure that this bucket isn't going to be deleted. This object store isn't going to be deleted anywhere. But you'll notice there's the snapshot right here. So we actually have it in there. Now, Melissa, we are going to go into the second set of Vault servers. I don't even remember.
Set.
Yes.
And then 203.
Yes.
To make it easy for the memory.
Right. And then we are going to need to run AWS install as well.
Okay. Do you want me to paste that command again?
I don't think the command pasted well from the chat. So
no.
I'm going to try to paste it on my side. 1 second.
Okay.
You know what? Because folks are wondering. So I have my own. Oh, so cool. But I have my own login to Boundary. I don't think anybody thinks that's that cool. But we're just controlling. We have access control on these instances. And so I just use my login to Boundary to do all of these functions. So you'll find out that there's a, I don't even know. Yeah, there we go. So I myself am also logged in. The sessions I can track. So I can track if it's Melissa or myself. And then if I do AWS help, I didn't actually install it. So we're going to install that. Is this too complicated? Is this over-engineered? I don't know.
I don't know. It feels pretty real to me.
Yeah, we know, the fun part is that we know that Rosemary's in one set of sessions and Melissa's in another. So I only see my sessions, by the way, if anybody's curious. You'll only see the ones that I have. I also have an active one open. I'll close that. But there's I know my sessions and I know where Melissa's sessions are, so I can track that. That's why after the stream, it's pretty nice because we don't have to revoke anything. If we do revoke something, it's pretty easy. We just rotate everything. All right. So now we're going to take it from the bucket down. Is it AWS S3 CP?
Yes. I was like, I'm going to try to do this command from memory. So
yes. And then we'll download it here. We'll see how it goes.
Everything else is good?
Yeah, I think so. Wow, look at that. We actually have it now. That was a lot simpler. Okay, so now that we have the snapshot downloaded to 1203, and just check vault status just to make sure we're not.
Yeah,
I gotta. Yeah.
That's what I thought, but I want to make sure.
Yeah, this is a very painstaking
typos
process.
galore. It's fine.
I'll ask the chat. Do you want me to keep TLS on the vault deployment? I mean, I guess it's good because then you get the reference of how to do it with the self-signed cert and all. But is it worth keeping it? I don't know. Initialize true, sealed false.
Okay.
This is the right one, right? This is green.
This is green.
Okay.
Should be.
Okay. I'm just going to double check.
Wait a minute. 1.203.
Yeah, you were on 1.203. Yeah. Yeah, so that's it. Okay.
Yeah.
All right. So I was like, wow, because we did initialize. I guess there's just nothing in it. So if you do vault secrets list.
Hold on.
Yeah, hold on. I think this is the second. Yeah. If you do a vault operator and whatever operator members, let's just double check. But I'm pretty sure that this is the second set of clusters. Oh, this is need better labeling.
It's fine.
Yeah, I think it is. Yeah,
This
it's
is
labeled green. It is labeled green.
Okay, so vault.
Yes. Keep TLS. Okay. Yes.
Operator.
Thank you, chat, for the
members
feedback. We need that.
Oh, right.
Your root token. Yeah. So definitely set your root token. We are close. We are so close. Restore procedure.
It's gonna be lovely.
Boop. Okay.
And for what it's worth, apparently a lot easier in the enterprise version. So if you're going to be doing this regularly, that might be something to consider.
Yeah, I think we're just running back and around, like turning around in circles though. Like we'll say that. Yes. It might just be us. So okay. All right, so we have it available, true, excellent. Okay, so nothing's happening. So just to show the group that we have nothing in this cluster, can we do a vault secrets list and just check what the secrets engines look like right now?
And it's a happy accident that 203 happened to be the active node as well.
Yeah. Okay.
So it's definitely not the same as the other one was.
No, it is not the same. All right, so let's do vault operator raft snapshot restore. And then we need to put force.
We're doing a
restore space dash force.
Oh, we love
and then
dash force.
Please work .snap. So the force is necessary because we have auto unseal and Shamir's keys that are not consistent with the snapshot data. So we need to force it to override it. Okay.
It didn't even say anything. It's like, yeah, whatever you want. Let's go.
Okay, now let's do vault status.
Oh, I didn't do a vault status yet.
Okay. We are
sealed
initialized.
And initialized.
Sealed, false.
Yes.
So did nothing happen?
Something happened.
Okay.
So we're going to try that other anymore. Key.
Yeah. As a note for folks, if after this step of restore, if you are using Shamir's, meaning the manual seal, not auto unseal on your cluster, you will have to unseal it with the unseal key. In our case, though, we use auto unseal with AWS KMS, so we don't need to do an unseal command. It already auto unseals theoretically with whatever's in KMS.
So this is the token from the original set of servers, the blue servers.
Okay.
And we're going to see. Yes.
Wow.
And we have the KV too. Look.
It's so cool. There you go.
Now that token command, what was it? It was vault token. No. Operator maybe?
Token.
It was just vault token?
Mm-hmm. Yep. Because tokens are something that you can issue outside of the operator function as well, right? So tokens can be issued by anybody who needs to access Vault and has sufficient permission. Operator is typically for backend functions with storage and things like that. So we'll do a lookup to check that the accessor is exactly what we expected. And
then the accessor, or do we need dash accessor?
We need dash accessor space and then the, what do you call it? I don't even remember the accessor.
Yep. And we've got that token down here. token accessor. Here we go. Boom.
Wow, look at that.
And it's there.
Nice.
Yay.
So Melissa, recap. What did we do? Omitting our churn of of like the 20 minute, 30 minutes we spent debating on how to SCP and hosts. Omitting that.
Well, I mean, we have to include that, right? Yeah. So we logged in to Vault and we tried to create a snapshot backup from a standby node, and that didn't work out too well. We also created a token on that node and added some secrets to KV melt. And then we moved off of that node and went to the active node, which is where you have to do the backup, and ran that snapshot command to do the backup. Then we copied it over to the new, to the S3 bucket, and then to the new server that we wanted to restore to. Restored, and then had to, of course, change our root token to the original root token of the server because it restored. And now we've got our old stuff up and running on the new stuff, which is pretty cool.
Yay. All right. So, and by the way, the 2 clusters are still up. So they're actually the downed cluster, the blue cluster, the cluster this originally came from is still up. We're just faking a scenario where you have to recover these things. So, you know, so for the most part, these 2 are pretty much identical. So if we wanted to add more to one cluster to another and add more to blue, it won't reflect in green, right? Because we're doing all this from backup. So I guess if you are using Community Edition, this would be something that's more like active passive, right? So if you always have a passive backup that you want to keep live, you know, just make sure you periodically back up the active one and push it out. And update it. And you could run the 2 separately. They just don't have replication between them. Alternatively, if you use Enterprise, there is replication. So this is all handled. So you don't have to think about that. But, you know, if you want to do this backup and restore so that you always have an active and passive setup for your disaster recovery for Vault, then you could do that as well. All right. So now that we've explored the world of backup and restore, it took us a while, but we have a little bit of time left in the stream. Melissa, let's talk about authentication, right?
Okay.
We briefly segued into tokens and the different, a different kind of like the different types of tokens earlier, just because we wanted to show that we could back up tokens and restore them, which yes, you can back up tokens and restore them. They will be just fine. And we created a token with a time to live. So the one that you printed out has some nice information to it. So we created one with a 2-hour time to live. And there's also some good information here, like when it expires. If you run inspect again.
Inspect.
Yeah, not inspect, lookup. Sorry, not inspect, lookup. If you do the token lookup command again.
Okay.
Yep, let's look it up. Mm-hmm. Okay, so you'll notice the TTL, right? The TTL did change. It does count down, right, on how much time you have left. Wow, how much time you have left on this token. We also have a number of uses, so we have 20 uses for this token. So let's give it a try as to what do we do? What happens with this, right? What we're going to do, Melissa, is we're going to use the token and try to run out on the number of uses. So rather than export vault token, what you're going to do is do vault_token equals with all caps, because we're going to do that locally. Mm-hmm.
Yeah.
We just want to override it for the duration of the command and not for the entire environment. But vault token equals, and if you can get that token that you, not the accessor, but the token value itself that we saved.
Yes. So this big long string here.
Mm-hmm. And the top with the HVSs.
Oh, yeah. Even longer string.
Even longer string. They did change the string length, I believe, the number of characters for vault token. It used to be much shorter. So that space, vault token lookup.
Like that?
Yep.
Enter?
Mm-hmm.
Okay.
Oh, did something.
Oh, there was a space between them.
Aha.
Silly space. Oh, my dog has come to join us.
You have all your pets coming to say hello today.
Yeah.
What is a live stream if a cat does not crash it?
Yes.
Okay.
There we go.
So
Way better.
What happened to num uses?
It went to 19. It was at 20 before.
Mm-hmm. Yeah. All right. So let's do something interesting. Why don't we try to look up that using this token? Why don't we try to look up the key that you put in the key value store? So you can keep the vault token part, but you do vault kv get. And then I think the mount was kv, right? Dash
Yep.
mount equals kv. And then the name was narwhals, right? As a secret. There we go.
Oh, wait, it might be narwhal.
Nope. You'll notice, what is the error message that comes back?
Pre-flight compatibility check returned 403. Please ensure client's policies grant access to path KB. That's a permissions issue.
Exactly. So we attached the default policy, which did not have the permission to read from the KV path. So as a result, we can't use this token to just read a bunch of secrets. Like I said, we'll go into the policy engine another time, partially because we're going to actually practice writing some syntax and playing around with it. But anytime you create a token, you do want to attach a policy to it to ensure that it's only able to access the secrets that it's supposed to. So from a least privilege standpoint, you want to make sure that you are only accessing the secrets that that token is scoped to get or allowed to actually access. All right. So the next thing we're going to do is let's run out of uses. So let's just run lookup like 18 more times, or run this 18 more times. I don't know. Just run lookup 18 more times. We're just gonna try it out because we did set a TTL that was a little bit. All right. So we're gonna try to look up, run out the number of uses on this token.
Ooh, -1.
So
there we go.
Yes. All right. So you'll notice that we ran it 20 times. We've tried to use this token 20 times, and now it's locked us out, right? So this is pretty useful. If, let's say, you want to do this for like automation, for a certain well-scoped bit of automation that you know is only going to run for a certain amount of time and with a certain number of times, you know, then you'll be able to expire the token by usage. Alternatively, you can expire the token by time. So Melissa, let's do what you wanted to do, which is create chaos. Let's create a token with an expiration, a very short TTL.
Okay. I think it's just create, right?
Yeah, vault token create -TTL. And then you can do 5 minutes, 1 minute. I don't know. Chaos equals, don't forget the equals for this.
Oh, yes.
Yeah. Maybe 2 minutes is better because it might take us some time to type in the commands.
Yes.
That's what I think about it. 2 minutes. And then don't forget space policy -default. Space dash. Oh, gosh. Yes, we are. I call this Chaos Pygmy Marmoset. It is a small monkey. Okay. All right. So we have a token with a duration of 2 minutes, right? So let's take this token and then let's run it as part of that lookup that we had, right? The vault token equals that, and then vault token lookup.
Okay. So saving just in case.
Mm-hmm.
And then token.
Mm-hmm.
Come on. I don't have all day boundary. There we go. All right. Caps.
Yep. Okay, so you have a minute left on this. You basically have a minute left, and that's all you can do, right? So let us. Do we want to let it expire? That is the question. Or do we want to renew it? Well, it doesn't have access to list secrets, which is fine. It also doesn't have a limited number of uses either. So if you do a lookup again, the other kind of set of attributes that you probably want to notice is orphan. We'll talk about orphan, but tokens can issue tokens, right? So we'll check out the vault token later, the vault root token later, and because we've issued a couple of tokens by now. There's 36 seconds left, so let's renew the token. So if you do vault token, do that, and then vault token renew. Okay.
Ooh.
So what this does is that it renews the token. When you do a renewal of any kind in Vault, whether it be a lease renewal or a token renewal, that means reset the timer on the TTL, on the time to live. So reset the timer. If you do a Vault token lookup again, Melissa, you'll notice that the renewal time has been set, and the expire time will correspond to the new renewal time. So on the expire time, it'll be.
Oh, here we go.
Yeah. So the last renewal time and the expire time. You'll notice that the expire time has changed, it's been updated, and that means that you can continue to use this token. Renewal is useful if you want to renew a token, the same token, for other purposes. So if you plan to use this token for automation, long-running automation, you might just decide, I'm just going to issue one token and I'll periodically, not periodically, but I'll renew it when I need to. So the next thing that Vault will ask you to do typically is to do, or Vault allows you to do, is revocation. What revocation will do is, what it will do is take away some of the tokens, meaning you can't use them anymore. So let's revoke the token. All right.
Oops.
Self. Yeah, revoke -self. We're going to revoke this token. And then we're going to do a token lookup again. You'll notice permission denied. And revocation means that token doesn't exist anymore. It means you can't use it. There's nothing you can do with it. So this is the root token. So keep in mind, this is root token. It is an orphan itself. So you'll notice it is an orphan token as well. But that is a general overview of token renewal, token revocation. There are actually other kinds of tokens as well, which is why I had to stop myself when I say there's a period.
With renewal, is there any kind of concern around renewing your own token a bunch?
Yeah. So the thing is, you cannot renew your token a bunch, right? What we're issuing is something called service tokens. There is something called a max TTL on this. So there's a maximum time to live that you can issue on these tokens. And what it will do is anytime someone tries to renew past that, it won't let you do it. So that stops someone from infinitely renewing a token. Infinitely renewing a token means you use the same token over and over and over, meaning you never rotate it. If it's compromised, you can then opt to rotate it. But if you know that whatever you're using in your automation isn't as secure as you want it to be, you have no compensating controls around how to secure its access to Vault, then you might consider putting a max TTL on a token so that you can't just infinitely renew the token over time. So we're going to do that now. We're going to add a max TTL. So first we're going to do Vault token. If you can run the Vault token create command again, and then -TTL, we'll give it 1 minute, right? Equals 1 minute, sorry.
Right.
Mm-hmm. And then explicit -max -TTL equals, we can make it 2 minutes. So we do that. And I don't think we need to attach a policy. It's fine. Maybe we need to attach a policy. We can do policy default. Yeah. Okay. So let's issue that. If you do this lookup on that token.
It's so short. Let's just do that. The 1 minute timer.
I
Very
know.
intense.
Very intense on the 1 minute timer. Melissa, how fast can you type?
Not fast enough.
Here we go. Look up. Okay. So you'll notice that there's 18 seconds left. Let's renew it. Token renew. Okay. Let's do that. Self. Yep. Fast. Oh.
What?
Oh, no, you don't need self. You don't need self. Quickly. All right. So let's do a vault token lookup again. Because only revoke needs to be self. Okay. So we have 53 seconds left on this thing. All right. So because we set a max TTL at 2 minutes, we should not be able to renew this again. Because what basically this means is that it will stop everything, right? It will not stop everything. It will basically allow you to stop infinitely renewing things. This way, you can't just keep renewing this token for infinite usage. Yes, you see this one.
And it will warn you that you're doomed.
Yes, that you're doomed. Well, this is exciting. We're trying to beat the timer here. All right. So that's what happens with service tokens, right? The general rule is that if you are doing long running automation, you probably want to set this to a longer max TTL and then force a rotation after a certain amount of time. But if your applications can't accommodate this, then you would do what is called a periodic service token. A periodic service token basically means there's no max TTL. So you can just keep renewing as much as you want to. As long as you renew, these periodic tokens will continue to exist. So Melissa, if you can run the command without the similar command without the max TTL, if you do a vault token create, and you can do it without the max TTL and then put period equals whatever, 24 hours or dash period equals 2 minutes. I guess we can do 2 minutes because, how fast can we type? I have no idea. All right. What this is a periodic token. So the token duration is 2 minutes. It's renewable. What this means is that I can keep renewing it as long as I do it within this period of time. So unlike the service token we created before with a max TTL, it will not stop me from using this token as long as I continue renewing it. So Melissa, if you could renew this token.
Or do I just do renew?
I think you have to do a vault token. I think renew you could pass the accessor actually, or you can pass something, but it's probably better just to do it this way. Yeah, vault token renew. Yep. So basically, if you do a lookup now, all this will basically tell you is that you've just renewed it. It won't time you out. It won't tell you that you have a max TTL. The idea is that you can just keep renewing this and keep doing it over a long period of time, especially if automation that is not going to do well if you do any revocation of those tokens and you're really concerned about because it's a very critical thing. It's a very critical application that needs access to vault or something. Now, typically, there are other ways that you would do this as well. But the token system overall, this is how you approach it. And that is a very, very helpful thing to do. Okay, so orphan tokens, we briefly mentioned this, but orphan tokens are not children's of parents. So you are on a root token, right, Melissa? So if you do a vault token lookup.
There we go.
Okay, so you'll notice that the orphan is true. What orphan means is that it is not going to expire. So if the parent of this parent token, if it had a parent token and it expired, then this token will not expire. This is a root token that's just going to continue living and continue being something you can use. Let's issue a token that is not we'll be issuing non-orphan tokens, but let's create a token, and you can set the TTL to 5 minutes. It's fine. Mm-hmm.
Just that?
You know what? 5 minutes. Let's set it to 5 minutes. Let's do
nothing else.
5 minutes. Yeah, that's okay. Just do 5 minutes. We're good. Sorry.
Okay.
I had to think for a second. All right. So we got the 5 minutes. Make sure to save the accessor because we're going to look up based on this accessor.
Just in case, I'm going to put it all in the notes file and then.
Yeah. Okay. We're going to take this token, this token, HVS. Yeah, we're going to take this HVS token. Mm-hmm. I don't know if it has permissions. Oh, no, it has root policy permissions. Yeah. That's perfect. Perfect. Okay. So we're going to take this token. What we created was a child token of the root token. Is this making kind of sense?
Yeah.
Okay. So we had the initial root token, which you have set. Then we created a child token of that root token.
Yes.
Okay. So let's look up this token. So if you do vault_token equals this token, the HVS DKU token. Token. How many times can I say token? Someone is eventually going to count this episode of how many times I say token. I feel like, all right.
I volunteer someone as tribute. Probably Cole if he's on.
Vault token lookup.
Okay.
Okay. So when we have vault token lookup, is this an orphan token or does it belong to a parent?
It belongs to a parent.
Okay, excellent. So we have 3 minutes left on this token. We're going to use this token to create another token. So we are using our grandparent token. This is the parent token. Now we're creating a child token. So yeah, we're going to do vault create token create. Let's set this TTL to 10 minutes. We'll set the TTL longer on the grandchild token. We're going to go, this is the terminology I'm going to go with. It seems to make more sense. Okay. So we're going to create that token.
Just boom.
Okay. Save this. This is the grandchild token that we have.
Yes. Yes.
Okay.
Save.
Okay. Excellent. Grandchild token. Okay.
There we go.
So we had the grandparent token. The grandparent token is not going to expire, or it will expire eventually, but we don't care. But the parent token is a root token that is not an orphan, meaning that it will expire in roughly 2 minutes, or probably shorter. And then we created a grandchild token, which is also not an orphan token. So what we're going to do is see if we can still use the child token, or the grandchild token. If you could do a vault token lookup on the parent token, not the grandparent token, but the parent token. I think we probably have to look at history.
Yes.
Yes. So there's a minute left on it. I mean, I guess we could revoke it. Or we could wait for another minute and 50 seconds.
Die. Oh,
self.
That's the one where you need self. Yes.
Okay. All right. So we've revoked the self, and now let's look it up. It should tell us no.
Oh, yep.
Okay. All right. Let's look up the grandchild token. So what we just did was we revoked the parent token.
All right.
Aha. So we cannot use the child token anymore.
But
yes. So why does this matter? The point is that sometimes when you have a larger vault deployment, you'll have a large number of tokens, right? Some of them are going to be used to issue new tokens to other people or other developers or other applications. And the important thing is that if you have a hierarchy of tokens, you don't want to leave the hierarchy sort of all individually managed on their own. There are some situations in which if you issue a root token, or if you issue a token that's able to issue other tokens, and that token is compromised, you might decide that it's probably worth just removing all the other child tokens that come from it. So in this case, you can revoke the entire hierarchy of tokens. You can, if you don't want to revoke an entire hierarchy of tokens, or an entire token chain, you can set the orphan token. You can set it as an orphan token so that it is not taken away after you revoke the parent. It is just it's a pattern that you can choose if you decide to use token authentication. But at the end of the day, a lot of the token workflow that we're showing here is actually abstracted by a different layer, which is an authentication method. An authentication method issues tokens and is using all of these functions underneath it, right? To say, okay, here's a set of orphan tokens, here's a parent token, here's a child token. These are the policies that I'm attaching to it. Here's the TTL for it. All of that is handled by an authentication method in Vault. You typically don't use directly the Vault tokens unless you absolutely need it for some critical automation that doesn't have an auth method involved. And even then, you would typically use a Vault app role auth method. You wouldn't really use a token directly. So there we are. Then there are many other tokens as well. But I'm not going to go too far into them. There are this is what we've done. What we've done today is service tokens. And then there are batch tokens as well. So I'm going to post some documentation on there so that folks can actually check out what this is. But there are some most of the time what we're going to be using are service tokens. And they're going to be something that you can renew, you can revoke, you can create these child tokens, right? A lot of these things are what underpins authentication methods in Vault. There are also things called batch tokens. Batch tokens are a little bit different. They don't have a TTL that you can define. You always have a fixed time to live for it. And you can't define it as an orphan. Most of the batch tokens are used for more lightweight actions within Vault. So not necessarily retrieval of secrets directly, but sometimes system components will use batch tokens. I have not necessarily used a batch token in day-to-day. Most of the time I'm using service tokens. But if you do have that, if you do need to use a batch token, I haven't heard of anybody who directly uses it. So if anybody has any feedback on that, do let me know. But they don't require storage, which is probably why it's a lot easier to use them in some ways, but they also don't have the ability for you to do any kind of revocation or renewal either. All right, so that's that. Do we want to get into an authentication method since we're moving along? Or Melissa, how do you feel right now?
I feel pretty all right.
All right. Let's do one authentication method because I think it will solidify what you mean, what I mean by tokens and why we don't actually use tokens. Most of the time when you are trying to authenticate from an application to Vault, you are not necessarily going to use a token. You do use a token underneath all of it. You just don't know you're using a token. So what we're going to do is we're going to set up an auth method. Now the question is, what kind of authentication method do we want to set up? There are a couple different auth methods. Auth methods take some kind of identity and then map it to a token in Vault. So this allows you to set access control as well as policies that you're going to define that allows some kind of authentication method that you're proxying to authenticate into Vault. So a good example of this, and we'll cover it more in a later stream, is I am on an AWS instance. How do I allow my AWS instance to authenticate to Vault? It's the secret zero problem, right? How do I get that secret from Vault into the AWS instance? I can use AWS instance metadata for it to self-identify, saying, "Hi, I'm this instance ID," and I can set up Vault to say, okay, anything with this instance ID or this metadata is allowed to authenticate to Vault and get this secret, right? So it's an easier way for you to automate the injection of secrets into your application or your virtual machine, wherever it is, your workload identity. You use workload identity to inject the secret into the workload. So that's the important thing about the auth methods. You're going to use this in a couple different ways. You can use it to allow human access to Vault. You can use it to allow workloads, machines, containers, anything you want into Vault. Underneath it all, though, it is using a token. So we are going to set up an auth method really quickly. The question is, what auth method?
Well, right now we have token.
We have token. You know what? Let's do username and password. I think that's a more simplistic one. We typically don't use username and password, but I think it will get the general approach. It will help you get the general approach. So the first thing we're going to do is we're going to set up a method. We're going to do vault auth enable, and it's user pass.
That's it?
Yep. So you can specify a path as well. Like if you have multiple usernames and passwords and whatever, or multiple, in the case of, let's say, GitHub, you have multiple organizations that you might authenticate to, then you might allow to authenticate into Vault. You can set it up at different mounts, right? So same goes as a secrets engine. Remember, we could define a mount for a secrets engine. You can define a mount for an auth method. So that allows you to choose whatever subdivision you want for your different types of authentication. But right now we have a user pass auth method enabled. Yay. Now we're going to add a user to authenticate to it. So it's a vault write because it does not have an auth subcommand. So vault write auth slash, and then you're going to do this user pass path. So anytime you have an auth method, you will always be under the API, the top level API auth path. So just keep that in mind. So you're going to do user pass slash users. And then you can name someone slash, sorry, user slash.
Space or no space?
No space. No space. And then password equals.
Ah. And then whatever I want to put here.
Yeah, whatever you want to put.
Terrible password.
Yay. And then policies equal default. Yep. Okay. So this is going to define a username of Rosemary with a password, a terrible password. This is kind of strange if you look at the syntax, right? Because you're like, this doesn't really help in terms of the, like, why can't I define username fields? Why, why is it's because it's accommodating for all of the auth methods, and it's using an API-based approach, an HTTP API-based approach. So anytime you write an auth method, into Vault, it will reference this API path, whether it be auth Kubernetes, auth AWS, auth whatever, and then there's usually sub commands that you'll pass in. So it could be users, it could be groups, it could, whatever it could be, it's defined by the auth method, right? And that's kind of where things are a little bit strange. On the auth method side, you have to know the API that you want to enable, as well as the fields that get passed to that API. So just keep that in mind. It's not going to be quite the same as the secrets engine, right? Some things are just not abstracted that way. So the interface is a little different. But now we have Rosemary, and we have Rosemary logged in. What we're going to do, just so that I can prove to you that we're not just making things up and we're not just using the root password, Melissa, is that if you could unset vault_token.
Ah.
Yep. Okay. So if you echo $vault_token, space $.
Yes.
And then no space between vault and token.
What do you mean no space?
Between dollar and no space between dollar
yeah,
and
yeah. Mm-hmm. Sorry.
No problem.
Nothing.
Okay, so it's not there. What we're going to do is we're going to now have to log into Vault using this username and password. So the first thing we're going to do is we're going to do a Vault login space dash method equals user pass. And then we're going to do, there's no dash, just username.
Oh.
No dash. Yep. All right. Username equals Rosemary. Yep. And you can, I think it will automatically prompt for password, but who knows? Yep. Yeah. Which is a bad password.
Look at that.
Yay. Okay. So what do you notice? What's interesting about this, Melissa? I used a username and a password to log into Vault, but what is interesting about this?
Well, I have a token and a token accessor and duration. It's a renewable token. It's got the default policies, which I remember we set as part of the username stuff. And then it's got its own meta username, which is kind of cute.
Yeah, it's metadata. It's metadata about that username. So what we've basically done is, as part of this authentication method, we've used it to log into Vault and get a Vault token. Now, if for subsequent commands, right, it already injects the token. So if you do Vault secrets, because it's a default, we're not going to be able to do anything with that. But if you do a Vault token lookup, for example, you'll notice that it is coming from Rosemary, user pass, and it's got 767 hours on it left. There you go. This is important. When you set up the auth method, you can configure how long the duration of the token is, for example. You can say it only has 2 minutes, right? It can only be available for 2 minutes. You know, all these things you set up at the auth method level. So when someone logs in, they get this token back. And then it means then they have to re-log in to Vault after that token expired. So overall, this is typically how you interact with Vault when you authenticate to Vault. There are a lot of other authentication methods, as I mentioned before. You typically don't use username and password. You typically, if you have automation that is tied to certain Vault roles and things like that, you can do something that's a little more manual called an app role, which is a little bit different than just issuing a bunch of tokens. So you chaos. You can do revoke self and remove it. I can see that look. All right.
Okay.
Yeah, now you can run lookup again, or you could try.
It hates me.
Yeah, see? So now you have to log in again and blah, blah, blah. That whole thing again.
It'll still let me log in?
Yes, but you have to re-log in. And what it will do is reissue a new token.
Look at that.
Yeah, there you go.
So it's not as bad as you make it out if you accidentally revoke your own token.
No, you just log in again. That's it. For more complex authentication methods, their sequencing is basically any time that the token expires or something, then it gets, anytime this token expires, then it has to re-authenticate, right? Alternatively, if you're using something like Vault Agent, it will just renew the token for you. So most of the time, this stuff is built into automation. Sometimes you will have to do manual renewal. You probably will do a manual revocation at some point if you're worried about that token being compromised. But other than that, this is Vault tokens and a brief introduction into authentication methods.
Yay!
Any lingering questions? I know chat has been quieter today, which is fine. You know, we appreciate the interaction. I also can't see what's going on the LinkedIn comments. I'm sorry, folks. It sometimes just doesn't funnel through correctly. But I promise I will go through and answer your LinkedIn comments if you have specific questions. But anything that we should review, Melissa? Any follow-ups or any questions that you have?
What are we doing next week?
Hashi Talks.
All right.
You're so disappointed.
No, I'm excited. But I was thinking in my head that we were doing next week, and I learned this morning that we weren't, and then I did not update my brain.
Oh, it's okay. It's okay. No,
I was still copying. My bad.
It's okay. You know, could we be streaming with Hashi Talks? I guess we could, but you know, why would we? It's a lot of going on.
It's a really bad idea to kind of double down on that, because I think I'm on the last shift for that. So.
Yeah, See, I'm telling you, it's a bad choice there. Bad
Poor
choice
choices.
there.
So
poor choice
please tune into Hashi Talks and join us next week for that. It will be a little earlier than our stream as far as starting times go. So we're gonna start at, I think, 8 a.m. GMT, maybe, and then go till 8 a.m. GMT. So if you're in London, we start at 8 a.m. For everybody else, just convert. I think it's 3 a.m. my time. I'm on Pacific time, so it'll be great, and that's on Thursday to Friday morning.
Mm-hmm. Yeah, which is why I don't think we want to just start streaming on the Friday afternoon afterwards. So, it's just a lot. But it is fantastic. There are some awesome talks that are lined up for it too. So you get to learn from our illustrious expert community, not me and Melissa, because we are not experts by any means. We are only somewhat more expert.
Rosemary, I think you're more of an expert than you let in.
Well, now we've backed up and restored a cluster. So
yes.
In terms of what's going on in the next stream, tune in on the 23rd. We will be exploring policies and probably turning on more authentication methods. We might get to secrets and leases. Some of these things might be compressed a bit, depending on our time. I thought we would take more time to do backup because I was worried it wouldn't work, and it turns out we were mostly okay. Yeah, we were okay.
As is tradition, it's always the files transfer.
Yeah, it's always the file transfer. It's either DNS, the network, file transfer. I have no idea. But on the 23rd, tune in. We'll be talking about vault policies. We'll be exploring the policy syntax a little bit more. And then we're going to set up the AWS authentication method. So that way, Melissa does not have to enter a username and password to get Vault stuff, or to get stuff from Vault. There we go. My brain just like, woof. Over here.
It's all good.
I know. And maybe we'll go into secrets and leases, maybe, but that's a whole other thing. And then we'll talk about dynamic secrets. Wow, because all we've done up to this point is static secrets, storing stuff in KV. That's that. I think that's the end of the stream. Tune into Hash Talks next week. Thank you so much for joining us. And if you are curious to learn more, we have the recordings for this. There is the repository available. If you're watching on YouTube or you need the descriptions and links to things, it will be in the description on YouTube as well. So thank you very much for joining, and we hope to see you on the next episode.
Thank you.